All right, so here, the 3.6, we're talking about marginals and differentials. And we'll talk more about the differential first before we talk about marginals. So we have seen this before. We have a curve and we have a tangent line in red. So nothing new, we've been working on that. And the point of tangency is right here at the x value. That's where we have the point of tangency. Now, if we go over a little bit to the right, delta x distance, then I would say this value here, what would this value be on the x-axis? Can anyone tell me? So if x was 5 and we went over 2 units to the right, what would our x value be? 7, I agree. So if it's x and we went over delta x, how did you guys get the 7? You added the amount it went over, right? I'm assuming that's why you got the 7. So if we went over delta x amount from to the right, so we went over this amount, so this x value becomes x plus delta x. Just as if we went over 2, it would have been x plus 2 or 5 plus 2. Now similarly, let's say this value here is y. And we went up this amount. So you here will see that we went up by delta y. What would a new y value be? You know what, let's change this. Let's not call it y. Let's call it f of x. So if this is f of x, what would the y value be up here? Or let's say here then, the actual y value. How do we find y value in a function? Come on, how do we find y value in a function? Let me help you. Let's say f of x is equal to 3x plus 2. Let's make this real simple. How do we find a y value when x is equal to 4? We plug in the 4, right? I agree, right? So we find y values by plugging in the numbers. So here this will be f of 4. How about if x is equal to 5? What do we do? Well, let's say x is equal to 5. We plug in a 5, right? So this would be f of 5. How about if x is equal to negative 3? What do we do? Come on, do plug in negative 3. Excellent. So to find the corresponding y value, we always plug in the given x value. Let's say x is equal to m. What do we do? We plug in m. Excellent. Let's say x is equal to x plus delta x. What do we do? Plug in x plus delta x, right? So this becomes f of x plus delta x. Same thing here, right? Since our x value is x plus delta x, we can find a corresponding y value by letting it be f of x plus delta x. Now we can see that. So this point over here on the left that we originally was doing is f of x plus delta x. Now, what would delta y be equal to in terms of the two y values on the left? Let me help you again. Let's say this is 7 and this is 3. What would delta y be equal to? 4. And I agree with you, Martha, right? Delta y is the difference between those two. So what's our delta y equal to now for those two values in red? What do we have, Martha? You can turn on your mic, you know that. It's probably easier. All right, how did you get 4? 7 minus 3. Exactly, you take the top number or the top value minus the bottom value, right? So what is delta y in red? So here you told me that delta y was equal to 7 minus 3. The green values. What we're interested in is the ones in red. What is our delta y equal to? No, it has nothing to do with numbers in green. What is the top number? Our top value. This is our top value here. And this is our bottom value. So delta y would actually be equal to f of x plus delta x, which is the top value minus the bottom value. There you go. Thanks, Lewis. All right. So this is the actual change in the y value. So in some of these questions, they're going to ask us to find delta y. And the way we find delta y is by using this formula. So make a note of this formula here. Because you'll be asked to find delta y a few times. Now, if we look at a tangent line, we'll see that which is in red, M is equal to, let's put this up here, tangent line. M is equal to f prime of x, which we already know. We know for the curve, we talked about this earlier on, the average rate of change is equal to delta y over delta x. y2 minus y1 over x2 minus x1, which is the change in y over the change in x. Now, if you look at the curve and the line, let's clear up some of this mess. As we get closer and closer to, if we follow the tangent line, we know the tangent line, the slope is very similar to the curve. And at the point of tangency right here, they're the same. So the tangent line has the same slope as the curve at the point of tangency. Do we remember that? No one remembers that? That's how we went from, in the very beginning, from chapter 1. So what we're saying here then is actually this. The slope of the curve, so this is a curve, and this is a line, are approximately equal to each other. And at the point of tangent, so they're actually exactly equal. But for small values of x, so the smaller this value is, delta x, the more closer they get to each other. I hope that makes sense to you. Now, where are we going with this? Well, let's take this a bit further down here. If f prime of x is equal to delta y over delta x, and we did some sort of manipulation like the cross product, then delta y is equal to f prime of delta x times delta x. Now, a couple of statements. So if we go back up here, we will see that this delta x is the same for the curve and for the line. So for this approximation, we replace delta x with dx, which is the approximate change in the line, and we replace this with dy. And this is going to be your second function here. So out of this is what you need to get. All I was trying to do at this stage was, derive the formulas or help you to understand how they came about them. If you don't understand anything or got a lot of that, just understand how to use the formulas, right? So you need this formula and the one above, which is the actual change in y. This is approximate change in y.
So can you repeat when you would use the second formula? And the first formula was to find delta, correct?
Yeah, which is the actual change in y.
Okay, and this.
All right, and they'll tell you. Also some word for this. So the dx here is called the differential of x, and dy is called the differential of y. So just some new terminology.
Okay.
And you know, they're saying the same thing we're saying here. So dx is equal to delta x, which is what we did over here. And dy is equal to f prime of x delta x. So this approximate change in y is actually called a differential. And it's also called the marginal. And we normally use a marginal for, you know, our business application, which we'll see. And we'll talk more about a definition for marginal. So I'm just going to summarize this here. So these are the two formulas once again. One is the actual change or the approximate change. All right, so here is actually question number 1 from MyMATLAB. It's a version of my number 1. So it's a 3-part question. Just find delta y for the given x and delta x value. So let's do this. Maybe this will help a little more. So we know delta y is formula number 1. We know delta y is equal to f of x plus delta x minus f of x. Now it seems a little more confusing than it actually is. But it's really just plugging numbers into the function. So we're going to find f of, what's our x value in this problem? 3.
The 3.
And our delta x?
Delta x 0.04.
0.04. There you go. Minus f of x, and x is once again 3. So this becomes f of 3.04 minus f of 3. So we're just finding the y value at 3.04 and the y value at 3 and subtracting them. That's all we're saying. Okay? That's a true y value. Does that make sense to everyone? It's kind of like going back up to here. When we said that, and Myrta was saying this was, and the difference was 4. So here, the y value here would be 3, and up here this would be 3.04, because we went up 0.04 on the x value, so we have to plug in 3.04. So just stick this into our function. Our function is 3x cubed. So this becomes 3 times 3.04 cubed minus 3 times 3 cubed. Is everyone following that?
Professor,
Yes.
can you explain why you did the 3 plus 0.04 minus 3 instead of 3x cubed? That's confusing me.
Hmm.
The extra 3's that's in front of the parenthesis. Not extra 3, but yeah, that kind of confused me as well.
I'm confusing you. So here's our function f of x is equal to 3x cubed, right? We're evaluating it with 3.04. So this becomes 3 times 3.04 cubed, which is what we're doing here. And we're also evaluating it with just 3. So it becomes 3 times 3 cubed.
Oh, okay, I see.
Which is what we're doing here, right?
Okay, okay.
I'm not sure. Marta, did I answer your question? Yeah, so that's all we're saying here. We're evaluating the original function with those two values. And actually up here, I probably wrote this the wrong place. So here, the x value was 3, and this x value is 3 plus 0.04, so it becomes 3.04. So to find the y value, we're finding f of 3, and we're finding f of 3.04. That's what we're doing, trying to do to get the two different y values. And if we have the two different y values, then we can find delta y by subtracting them. So that's all we're trying to do, just find the y values. Did anyone get an answer for any of these? What was the answer for 3.04 when we plug it in? $84.28. Anyone confirm that? Okay, and for 3, 81. Okay, so our delta y then would be equal to 84.28 minus 81, which would be 3.28. Is everyone okay with that? So it's like Lewis, it's not bad, but it does roll in some of the earlier concept. And this is part B is where, we're rolling in most of the. So let's go at part B. Part B says dy is equal to f prime of x times dx. So we have to find the derivative of the function.
Okay.
Right? So what is the derivative of that function?
9x squared.
I agree with you. So dy is equal to 9x squared times dx. There you go. That's part B. We're done. Part C says, we're going to evaluate part B by plugging in the values for x. So dy is equal to 9 times 3. Yes, we do. Because it's times the dx, Martha. 3 squared times dx, which is 0.04.
Okay.
What do we get for that? It's 3.24. Did anyone else get 3.24? I got the same. So dy. So this is our dy. Now let's look at our delta y. Our delta y is 3.28. Would you say the answers are kind of close? Okay. Which one was the least amount of work? Delta y or dy? Which one? I agree, right? And so on the right side is actually pure algebra, right? What we are finding the delta y. And it's a lot more work so the calculus here, even though it's not 100% accurate, it's a very good approximation, and we use it more often than not than the actual values, because it's so much more or less work than going through all that algebra. And that's what they're trying to emphasize up here, that the curve itself is very close to the tangent line is very close to the curve, especially for small delta x. Because for small delta x, like very close here, look, they're almost identical. You see that whole region there, they're the same. So the smaller the delta x, the closer we will get to the true value. All right, let's try this. This is problem number 8. How do you think we find delta C here? No. Remember, delta When we use the delta form, delta C, we're actually trying to find the original, right? The true change. And the true change is always going to be f of x plus delta x minus f of x. So that doesn't have the derivative in it. Okay, Marta? So for this, to find delta C, this would be f of, well, that's not f of, but c of x plus delta x, because its function is c, minus c of x. Is that number 7? Is that what you're saying? Yes, it is number 7. All right, so what are we plugging in? 80 and, well, x is equal to 80. So this is 80. This is 1. And this is 80. So we're finding c of 80 plus 1, or c of 81, minus c of 80. So what do we get for c of 80? 1. Yes, or delta x in this case, would be 1. So delta x is 1, which is why we're plugging in 1 here. So we're plugging 1 and 80, which is why we have the 81 down here.
We're plugging the C of 81 into the total cost function, right?
Right. So we're plugging 81 in the original function, and we're plugging, so which is this?
Okay, so for C of 81, I got 154.21.
154.21?
Yeah, that's what I got.
Okay. Anyone else got 154.21? Okay, thanks, Michael, for confirming that. How about C of 80? 152. And when you subtract those, we get $2.21. So the change in costs for 1 unit was $2.21. And that's the actual change in cost. Let's do C prime of X, because that's what they're also asking us to find. So we know C of X itself is equal to 0.01 X squared plus 0.6 X plus 40. So we're finding the derivative of that, which becomes 0.02 X plus 0.6. Does everyone agree with that for the derivative? Okay. And they say to find that when X is equal to 80. So let's plug 80 into this. $2.2. So $2.20. And for these dollars amount, always put 2 decimal place, okay? So what can we say now? Are these close enough? You know, if we go back to the dy, we know that dy is equal to what? C prime of x times delta x. Do we agree with that? Back to our original formula. It's a derivative times delta x. So this would be $2.20 times delta x, which is 1, which is $2.20. So our dy, the differential, is actually equal to the same thing as the instantaneous, only because we're going up by a unit of 1. So, and this is what this is known as a marginal cost, right? Cost of increasing production by 1 unit. And similar to marginal revenue would be the revenue by increasing 1 unit. So the approximate here will just always be equal to the instantaneous, because we're only going up by 1 unit. And once again, you can see that the approximation, which is $2.20, is very much similar to the actual cost, which is, it's just off by 1 cent. Let's see what our next problem is. Number 3. Is this our number 3? Yep. All right, so number 3 says they give us two functions here. So they give us r of x and c of x. The first thing they ask us to do is find p of x. And by now, everyone knows how to find p of x, right? What does p of x represent anyway? Someone tell me. Which is the profit, right? So that's what we're trying to do. So profit, or p of x, is always equal to the revenue function minus the cost function. Don't leave out of this class without knowing that, right? You're business majors for the most part. I hope so.
Yes, sir.
Profit is always revenue minus cost. So this becomes 7x minus 0.002x squared plus 1.4x plus 50. And when you distribute that, that's 7x minus 0.002 x squared minus 1.4x minus 50. And when we combine the x's, that should give us 5.6 minus 50. So here we go, that's part A. Find the profit function, p of x, assuming we made no errors. Part B says find r of 50. How do we find r of 50? Come on. We plug in 50. I agree, right? We find there's no derivative or anything there. We're just plugging in 50. So this becomes 7 times 50, which is 350 according to Samuel. I agree with that. So we're going to find C of 50 also, which might be a little more challenging. But you're just sticking it into your calculator, right? 0.002 times 50 squared plus 1.4 times 50 plus 50, which is equal to, Samuel, that 5 is a oops here, or 125, Michael, for this? Is that what you're saying, Michael? Okay. Anyone confirm the cost? Okay. So the revenue for 50 units is basically what you're saying is $350 and the cost is $125. Now we're going to find a profit of 50. How can we do this? What can we do?
Plug it into the P of X.
Very good. I agree with that. Or John has a brilliant idea. Just subtract the two numbers that we already have, right?
What's the idea? What's the idea?
He wrote it in the chat box. He just says take R of 50 minus C of 50. Since we already did that, right?
Oh, yeah.
It was not a lot less work. So that's 225. I mean, you could plug in 50 up here in the revenue in a profit function and still end up with 225, but it's more work. We're always trying to do less work.
Yeah, we already found it.
Yeah. Part C says find R prime, C prime, and P prime. No. Trying to copy this and put it down. That's why it copies. All right, let's do it the old-fashioned way. So R of x is equal to 7x. And our C of x is equal to 0.002 x squared plus 1.4 x plus 50. So R prime of x is equal to 7. And C prime of x would be equal to 0.04 x plus 1.4. All right, how about, so quite a few answers for this one question. We're going to find P prime of x. And what would that be? We can subtract these two again, right? So it could be 7 minus 0.04 x plus 1.4, which is negative 0.04 x plus 5.6. Or you could go up the top and take the derivative of the profit function, which is going to give you the same thing. So this is P prime of x. Now all of these are, the derivative is a marginal revenue, marginal cost, marginal profit once we plug in the numbers. And we are going to plug in the numbers, which is 50. So we're going to find R prime of 50. We're going to find C prime of 50. And we're going to find P prime of 50. Well, this is 7 because there's nowhere to plug in anything. What is C prime of 50? It's 3.4. And these are in dollars, so. And P prime of 50. It's 3.6. And how did you get at 3.6?
Yeah, can you explain how you got a 3.6? And
Well, we could do R prime of 50 minus C prime of 50. Or you could plug 50 into this. You're going to get the same thing. Does that make sense, Louis? So right? So we're just trying to do it the easier way by plugging to subtracting. So this will be negative 0.04 times 50 plus 56, and that should give us the 3.6.
Okay. After calculating.
But if you have the revenue and the cost, it's always easier to just to subtract both of those to get the profit.
Gotcha.
All right, what does these numbers represent? Did they ask us that? What does these numbers, they didn't ask us, but I'm asking. What does these numbers represent that we just found? So once again, these are the marginal, right? But what did that mean to you, Don?
If you add one more dollar,
So one more dollar, but you're on the right track. It's one more unit, right? So this here, this revenue here, this means that if we produce one more unit, it would cost us $7. So if you produce the 51 unit, it would cost us $7 more, so our cost would move to, our revenue would move to $57. Does that make sense? It would move to $57. It would move by $7. And here, by producing one more unit, our cost would increase by $3.40. And our profit would increase by $3.60 for one more unit. If you go back to the top, once again, let's see if we can copy this. This was part B. Really? But this is what I'm drawing your attention to. Let's look at it. The revenue here is $350 for 50 units. What would our revenue be for 51 units? Well, it would be $7 more, which is what we're saying down here, right? Because our marginal revenue is $7 per unit. So this information is telling us how much more revenue would we make per unit above that 50 unit amount.
Okay.
So 51 unit, it would be $350 plus the $7, which would be $357. Our cost would increase by $3.40. Does everyone understand what I'm trying to say?
Yeah. If you made two, if it was 2 units, it'd be $14 in revenue, right? And then if it was,
Say that again, Luis.
can you go back up? Yeah. If it was, for example, if it was 2 units, you'd be getting $14 in revenue. It'd be at
Exactly. And those are the type of questions they're going to ask us soon,
6.
right?
I understand.
Because I'm going to, so R of 50 was equal to, Samir, you laughing at me? I just don't want to move on until you get this, and the cost of 50 and the profit of 50. $125 and $225. So Louis, kind of like what you were saying just now. No, it's not in this particular question. I mean, this already has like 8 parts already.
Yeah.
All the questions are going to ask us to find R of 53. Use marginal revenue. Now, what you're saying is that this would be equal to R of 50 plus 3 times R prime of 50.
Yeah, 3 times. Well, 3 times. Well, I don't
Right?
know. I would just say 3 times 7 just to keep it short in my head.
Yeah, but this is what, in mathematical, this is what I understand what you're saying. So this would be 350
Yeah.
plus
I think I learned how to
7
do it.
plus 7 plus 7, right? Because we're going up 3 more units.
Yeah.
So for every unit we go up,
Damn,
we're adding $7. And since we're going up 3 more units, it's 3 times 7, which is 21.
they wouldn't give us the marginal though, right? We'd have to still find it.
No, they're gonna always ask us to find it.
Yeah, then we go from there. Okay. Gotcha.
Well, the good news is they give us the functions at least.
Yeah, just plug in.
All right, let's look at this one. We have time 902, probably.
This is still 3.6.
This is still 3.6.
Okay.
3.7 is pretty short. But we won't cover it today. That would just. And you know, I've not had a problem with my MATLAB over all this time. Everyone has been complaining. Maybe I was just lucky. I saw that. I couldn't, Samira, I just emailed the entire class. I didn't respond to everyone because I got 19 emails from this class. All right, so here is number 4, I think it is. Let's make sure. All right, let's do this one. Suppose the monthly cost in dollars of producing X shares is given by Cx. C of X is equal to 0.01 x to the third plus 0.07 x squared plus 19x plus 600. And 50 shares are produced currently. All right. Let's do part A through, let's do part A. And we'll work on the rest of it. But you guys are doing part A, I'll take the role. I don't think you need me for part A. Is Jahan here?
Here.
Lewis is here. Reggie?
I'm here.
Reggie?
I'm here.
Okay. Brianna?
Here.
Cameron? Not here. Haley?
Here.
Tioni?
Here.
Daler?
Here.
Joe? Is that Joe? No? Jaren?
Here.
In the meantime, you guys can put some answers on the board for that part. Jose?
Here. Sorry I'm late.
Jenny?
I'm like super late, but my internet was down.
Okay, Jose, got you. Jenny's here. Faith? Faith? Aaron?
Here.
Don? I know he's here. Damien? Here. Chad?
Here.
Kathy? Anika? Anaika? Not here. Kida? Not here. Samuel?
Here.
Carlo? Carlo? Carmen?
I'm here.
Neil? Not here? I thought I saw you earlier. Samira? Here.
Here.
Valeria?
Here.
Anika Hill?
Here.
Michael?
Here.
Marta?
Here.
Francis? Alfred?
I'm here.
Dashka? Dashka?
Here.
Alden? Alden here. Dylan? Dylan?
Here.
Martha?
Here.
Transitio? Not here. Dylan. Okay, got you, Dylan. All right. Answers for part A. No one yet? How do we find the current monthly cost? I did. What? Two completed. All right, so we have 2 for 1850. Don, you want to check that answer since you're the outstanding one? Anyone else confirm Don answer or Reggie or Cad? You got 1850, Louis?
Yeah, I got that as well.
Okay. And the way we're getting that is because we're finding the current cost. And so all we're doing is plugging in 50 right here. So this is C of 50. So just 0.0013 times 50 to the third plus 0.007 times 50 squared plus 19 times 50 plus 600. So the cost is $1,850 of producing 50 units. What is the marginal cost when X is equal to 50? How do we find the marginal cost? That's just C prime of 50, right? But of course, we have to find C prime first. What is our C prime? The derivative, which is 0.003x squared plus 0.14x plus 19. So Louis, this is kind of like I was saying earlier. Some of the concepts are still mixed in.
Yeah.
Right. You need to know all these derivative rules. And now we're going to plug in 50. So this is 0.03 times 50 squared plus 0.14 times 50 plus 19. $33.50. What does that $33.50 represent? It's the marginal cost. But what does it represent? The cost of producing one more chair,
Cost per unit.
right? So marginal cost or profit or revenue is always a amount for producing one more unit.
Or losing? Is the same concept work with losing a unit?
Say that again?
Like, no, never mind.
You sure?
I was saying, like, if you're losing, that wouldn't make sense. But,
If you're losing,
like, if you're losing a unit, like, if you were, like, not making, like, you were not producing or whatever, not having another chair, like, could you lose that same amount?
well, it's unlikely that your costs are going to go down for producing more units. The cost per unit might go down because you're mass producing, but you will still have cost associated with producing more. Does that make sense to you?
Yeah. The reason that question came out is because I'm into like investing or whatever, so I have a familiar as far as margin. So I was just thinking of it another way, but yeah, I get what you're saying. I understand.
Okay. All right, let's do part C. So use the results from part B to estimate the monthly cost of increase in production to 52 chairs per month. So this is going back to the discussion we have a little earlier. We know the cost of producing 50 chairs. Would be equal to the cost of 50 chairs plus, $33.50 plus $33.50 because we're adding 2 more chairs. Does that make sense? Or what we were saying earlier, this would be the cost of producing 50 plus 2 times the marginal cost of 50 chairs, which is the same thing here. And we already have this number as $1,850 plus, 2 times 33.50. What do we get for that? So what's that, $67? So 1,917. Did anyone get that? Okay. And then part D says, what would be the actual cost of producing 50 chairs? How do we find the actual cost? We plug in 52 here now, right? Because this is a cost function, so we're finding C of 52. So this is part D. What is the answer for that? Luis, you have a lot of birds in your yard. Louis, did you hear me?
Yeah, I heard you. I get that. That's what I
I can't get a note. Don't worry. Can you hear them in my background? Maybe not. All right, did we get an answer for the 52? Because it's time to go. $19.17. And what do we get here? 1917.89. So this is the actual cost, and the approximate cost was 1917. I mean, not much difference in the approximation versus the actual cost. It's off by 89 cents. All right, any questions on this before we call it a day? See you guys next week.
Okay. Have a good one, Professor.
You too, Luis. You guys have a great weekend. We'll continue on Monday.
Professor,
Yes, sir.
what do you